Hi there. In this video, we're going to be talking about exact differentials. This series of videos now is going to focus on integration of multivariable functions. Thus far, we have primarily focused on differentiation. So when integrating multivariable functions, we have to recognize if it's an exact differential. So an exact differential basically tells us if a function that is a multivariable function can be integrated or not. We have seen in the previous videos that z, which is a function of f and y, can be represented in terms of its differential, that is the function differential, being equal to dz dx times dx plus dz dy times dy. So if we are just given dz, if we are told that there is some function dz and it's represented in this form, can we integrate dz and then obtain z? How do we do this? Well, we can't just do it. We have to establish if this function dz is an exact differential. So let's just write that down as a point. We can integrate dz if it's an exact differential. So this is an important point. So what we're going to do next is recognize how we are able to see if a function is an exact differential. So our function z is equal to dz dx plus dz dy. So what we do, we call this first derivative p and this derivative with respect to y q. So we let p equal dz dx and we let q equal dz dy. So we now find the derivative of p with respect to y. So what we're going to find is dp dy, dp dy is equal to dz dx. Remember that now it's a second derivative with respect to y. And we now find the first derivative, we now differentiate q with respect to x. We say dq dx is equal to second derivative of z, initially with respect to y and now with respect to x. And what do we know about mixed partials? Mixed partials are equal, right? So you can see that in probably the second video, I think, in this series. So since mixed partials are equal, we can say that dp dy is equal to dq dx. So this is how we determine if it's a function differential. We simply take p, which is dz dx, we differentiate that with respect to y, then we take dz dy, differentiate it with respect to x, and then we check if they're the same. If they are the same, then it means that it's a exact differential. We can just illustrate this in an example. So let's just write this down. So this means it's an exact differential and can be integrated. Therefore, can be integrated. So if our example says that dz is equal to 3x squared plus 4y squared dx plus 8xy dy. And now the question is, can we differentiate z? How do we differentiate z? So how we differentiate z will be the topic of the next video. But before we do that, we simply check if dz can be integrated, and we check if it's an exact differential. So we let p equal to this first part, that's 3x squared plus 4y squared, and then we find day p day y. So this is equal to 6x, sorry, it's equal to 0. We're not differentiating with respect to x, we're differentiating with respect to y. So first term is 0, and then second term is 8y, 2 times 4. Then we let q equal to 8xy, and then we find day q, day x. So we treat y as a constant, so remember it won't change, and then what do we get? We get 8y. And what do we notice? We notice that day p, day y is actually equal to day q, day x. So this means that dz is an exact differential. So one last example. We have dz equal to 1 plus 8xy dx plus 5x squared dy. As before, we let p equal to 1 plus 8xy. We find the derivative of p with respect to y. That simply gives us 8x. Then we let q equal to 5x squared, and then we find the derivative of q with respect to x. And this gives us 10x. So what do we see? We see that day p, day y is not equal to day q, day x. So therefore, this is dz is not a exact differential and therefore cannot be integrated.